Okay, now we're going to look at session 1, part 3, which is earthing. At the end of this part of the session, you should all be able to explain why we need earth wires, and list some components that would need to be earthed. Also need you guys to be able to describe some of the key differences between main equipotential bonds and supplementary bonds. And I also need you guys to be able to recognize earthing systems from their descriptions as either being TT, TNS, or TNCS. Well, firstly, what is earthing and why do we need it? Earthing is there to protect us from electric shock, and essentially it does it by providing a path for the fault current to flow to earth. Interesting point, electricity will always take the path of least resistance. So if, for example, there was a live wire that was in contact with some metal casing, that metal casing also had an earth wire attached to it. If somebody touched the metal casing, the electricity wouldn't flow through the person, it would flow through the earth wire because it had a much lower resistance. It's much easier for the electricity to flow through the earth wire than it would be to flow through a person. If it didn't have an earth wire connected to it, then an individual touched it, then that person would receive an electric shock. Now, what should be earthed? Essentially anything that's conductive that could be a hazard should be connected with earth wires. This could be like electric drills, but it could also be sort of other machinery such as washing machines, etc. Anything with a power cord, essentially, as well as things like structural metalwork, structural metalwork that could be accessible, and importantly for us, metallic pipework. Earth wires are normally green and yellow, as you probably already know, and tools and equipment would be earthed using the earth wire inside the supply cable. Exposed metalwork would have separate cables connecting it, like you can see here. An example shown here is an example of supplementary bonding, and we're going to talk about what that means very soon. Okay. Firstly, though, we're going to look at main earth bonding or main equipotential bonding. And these would be a minimum of 10 mil. Okay, the connections to our cold water main would be done with 10 mil cable as close as possible to where the pipework enters the house. And again, 10 mil cable should go to our gas pipe, which would be connected within 600 millimeters of the gas meter. Supplementary bonds. Supplementary bonds would be used wherever there's likely to be a break in what we call continuity. If, for example, you had metal pipework that was connected with plastic fittings, you'd use supplementary bonding over the fitting. And the reason for that is, if, for example, you had your main earth connection on the left-hand side of the fitting, but an electrical wire came in contact with the pipe on the right-hand side of the fitting, that electricity wouldn't be able to flow to earth and therefore would create a hazard. And so what we should do is we should make sure that we put supplementary bonding over any plastic joints that we might use on metallic pipe. So yeah, we use supplementary bonds anywhere where there might be high risk as well. Normally, sort of the pipework as it goes into a boiler will quite often have supplementary bonding on it. Also, generally speaking, you'll quite often see it in bathrooms, supplementary bonding in bathrooms, and possibly where around a cold water storage system as well. Worth noting, supplementary bonds should be a minimum of 4 millimeters cable. Another type of earth bonding that we need to be aware of that we have sort of touched on already in our safety module is our temporary bonding. Okay, whenever we cut into pipework, we should use temporary continuity bonds. The reason for that is if the pipework was live and you then cut that piece of pipework, there will be then sort of the electricity will no longer be able to flow to Earth. If you then pick up both sides of the pipework to joint it, for example, the electricity will then flow through you, and that could potentially be very dangerous. So what we should use is temporary continuity bonds, which would have a minimum of a 10 mil diameter of multi-core cable from one side to the other. There's some things that don't need to be earthed, and obviously plastic systems, if we run all of our pipework in plastic, then it wouldn't need to be earthed. And if you've got a double insulated piece of equipment, that would also not need to be earthed. Double insulated essentially means that there's two layers of insulation between the line wire or live wire and the person using the equipment. And the symbol for it is two squares, one inside the other, like you can see just here. Earth bonding system types. There's three types of earth bonding system: TT, TNS, and TNCS. The T stands for terra, which is Latin for earth. In our case, we'll use it to mean neutral. Okay. C stands for combined, and S stands for separate. So the first one, TT, or earth to earth, the TT system. TT system is the simplest type of earthing system, and it's the only one in which the main earth wire actually remains the responsibility of the property owner. Essentially, with a TT system, the earth wire would run out to an earth spike, which would be buried in the ground, and the earth would literally be going to earth. Okay, would be going to the ground. You can see an example of it here. Got an earth spike here with our earth wire connected onto it, earth to earth. TNS, a TNS system, earth neutral, separate, earth neutral, separate, is essentially made by making a connection from the main earth terminal with the main earth wire, which would then be connected onto the sheathing of the armoured cable of the main supply as it comes into the property. And you can see an example of it here. So we've got a cable coming in here with the main earth wire connected onto the sheathing just there. Our TNCS system, terra neutral combined separate system. This one, the earth is actually combined in with the neutral. So the main earth wire would sort of come from the main earth terminal, it would go into the supplier's main fuse, and it would then be connected into the supplier's neutral wire in there. You can see an example of it here. So we've got a cable coming here, going into the main fuse wire, main fuse box, excuse me, sorry. Okay, and now it's time for your task.